everyone. Today we are going to be talking about if statements in this if statement workshop presented by Bhavya and Justin. So to start off, we'll introduce ourselves. So I am Bhavya. I am currently a sophomore here at Carnegie Mellon University, and I'm studying a major in business administration with a concentration in finance. And for CS Academy, I am on the outreach team currently.
Hello, everyone. My name is Justin. I am a junior here at CMU. I study mechanical engineering and I minor in design. And I've been involved with CSA for over a year now. And I've been a part of the Spanish, outreach, and design team here.
So we can start by introducing the content a little bit about what we're going to be talking about today. So we're going to be talking about if statements and a lot of things that you can do with if statements. If statements basically are when you write code for specific scenarios, so on a case-by-case basis. If you see, we have an example of what these if statements will look like on the right. You basically want to use them when you have code that you want to write specifically for when you have different scenarios or you're in different states of your program. So you check if a specific condition is true, and if that condition is true, then you'll write some code that you want to execute. If that condition isn't true, then that code won't execute. And this you can see is also shown with the indentation. So after the statement or the condition is checked, if it's true, then the indented code will run. And then after that, what will run after that is according to whether or not it was true, which we'll get into a little bit later. And then elif statements are similar, except they're additional conditionals. So they happen after if statements and before these else statements. And else statements are when no other scenario is true, then it will run. There are a lot of caveats in terms of when you can use elif statements or else statements and things like that, which we will also get into in this presentation.
Tip number 1. Let's start talking about nested and inline conditionals and what they are and how we can avoid running into issues. So I've seen time and time again, both students and teachers make the mistake of accidentally setting conditionals inline when they should be nested and vice versa. So let's take a look at what it means for conditionals to be inline or nested in the first place. When conditionals are inline, as we can see on the left, all conditionals are lined up or along the same column, so to speak, not separated by any spaces or tabs. In contrast, nested conditionals are tabbed inwards. So the way that Python reads these are in order of outermost to innermost, or left to right, more simply. Nested conditionals are only accessed after the conditional above it or the conditional that it is nested under passes. So as I show in the diagram, the second if statement in our nested case, the second if statement cannot be accessed or run when the conditional above it fails. It is very much dependent on the statement before it, which means order is imperative. Inline cases, however, will all be checked and run regardless of whether or not conditionals above it or below it pass or fail. These if statements are independent of each other, which means both cases could pass or both cases could fail, or one passes and the other fails. They are not dependent on each other. We can get any combination of them passing or failing. Whereas in nested conditionals, the outermost has to pass before we can move on to the one nested underneath it or below it.
So we can start with if-elif statements. I have provided an example up at the top, a very simple example. So we have this on mouse press function where when a mouse is pressed on this canvas that we have before us, then it takes the on mouse press function is called and it takes in the X and Y coordinate for the mouse click that does happen or that executes. And then it stores the X coordinate in mouse X and the Y part of the coordinate in mouse Y. So for an if statement, we can use these arguments that are given to us in the function. So for example, in this one, we see if mouse X is greater than 200. So this is a 400 by 400 canvas. So if mouse X is greater than 200, that means that the mouse was clicked anywhere on the right half of the canvas. Since there's nothing regarding mouse Y, the Y coordinate does not matter in this scenario because this is a very simple example. So if the mouse is clicked anywhere on the right side of the canvas, then that conditional is true. And then it will execute any code that comes after it. So in this example, I have written the code, since it's only one line, I've written it right next to the if statement. But if you have multiple lines, then you will put a semicolon after the 200 close parentheses, and then you will bring all of that code down underneath the if statement and you will indent all of it. So it'll work that way. And so if it is true, then it is basically printing greater than 200. So that's what we see on the right over here. That's like what the print statements would look like. So it would say greater than 200 in this case. So the Y coordinate doesn't matter at all in this case because it's not included in any sort of condition or in the if statement. So anywhere on the right side, whether the top of the right or the bottom of the right, if the mouse X is on the right, then this greater than 200 statement will print. And since there's nothing following this if statement, if the mouse click does happen on the left, then that condition will be false and nothing will be printed at all. It would just be blank. So we can make it a little bit more complicated by including an ELIF statement. So an ELIF statement is an additional condition that can be checked if the previous if statement does not ring true. So for each you can have if, elif, and else statements sort of together, and you can check a range of things within them. But elif statements will always have to be after one if statement, at least one if statement. So if the mouse X is not actually greater than 200, then the if statement will be false, and then the elif statement will be checked. And if the mouse X is greater than 200, then it will just execute the code for the if and it will stop after that. So if anything above an elif statement that's sort of connected to it, so in this case, if this if statement is true, then the elif statement won't even be checked because it is elif. If you want both statements to be checked, then you have to just make them both ifs, which we'll talk about on the next slide. So in this case, if the X coordinate is on the right side of the canvas, then it will print greater than 200. If it's not on the right side of the canvas, then it will go and check the elif statement. And then the elif statement is saying if mouse X is less than 100. So if it's in like the left quarter of the canvas, then the elif statement will be true, and then it will print less than 200. It's important to note, if you look on the right where the print statements are, that only greater than 200 or less than 100 will print. Both of them won't print together at any point with this code. And the number of elif statements you can have after an if statement is pretty endless. It depends on how many different sort of scenarios or cases or conditions you want to check. But if you do an if statement and then another if statement and then an elif statement, then that elif statement is only connected to the if statement. So it's only connected to the if statement above it. So the first if statement will run, and then if the second if statement is false, the elif will still run. So now this is an example of two if statements right next to each other. So in this case, it will first check if mouse X is greater than 200. And if that is true, it will print greater than 200. And that's sort of done. There's no like elif or else statements after it. So there's nothing that needs to be skipped. And we just move straight to the next if statement. And then it asks if mouse X is greater than 300. So if the mouse click is greater than 300, both greater than 200 and greater than 300 will be printed. But if the mouse X is somewhere between, like if it's greater than 200 but less than 300, then the first if statement will be true, but the second if statement will be false, and only greater than 200 print. And in this scenario, if the mouse X is greater than 300, then both of them will print, obviously, but there's like many different ways that you can phrase these if statements. So if you're like trying to decide, like trying to go up higher and higher. So for example, if you have if mouse X is greater than 300, and then you have if mouse X is greater than 200, that will change the outcome based on where things are clicked. So the order of if statements do matter if you are trying to print many lines of code, if you're just trying to print one specific line of code. So you have to be careful with if statements versus elif statements if you want to check many or just one or the other. And then you also have to check the order of your if statements or your elif statements.
Tip number 2, let's think about elif statements as a series of pipes. So let's think of them as creating a chain, sort of a line of action from left to right or from top to bottom that goes in order of, most important being the top and moving downwards as we fail the cases. So what does this mean? So in contrast to our inline if statements, as we saw in tip 1, where multiple if statements could pass or fail regardless of the order, elif statements create a one-way path. So as Python goes down our code, it'll start checking the first if statement. If that statement doesn't pass, our water or steam, whatever we want to think of it as, we will be closed off and will be sent down the following connection or the next path in our route. This elif statement in our diagram passes, and Python follows through with that conditional, and every statement afterward is closed off and skipped entirely. So it's one inlet, one outlet. Let's talk about if-else and multiple if cases, and when we would want to use one over the other, and what it even means to use elif or if-else and multiple ifs. So let's differentiate between cases where we use if-else and cases where we use multiple if conditionals. If-else statements, as we might have seen before, check any conditional before the else and will only pass to the else if all statements previously fail. If the first condition passes, Python runs its code and skips over the else, whereas the else statement passes only if the conditional before it fails. The difference between else and elif being that else has no set case to pass or fail. There is no, else. There's no question that we're asking. Else doesn't ask a question. It doesn't have any condition to meet other than everything before it fails, and Python is able to reach that else case. So it runs as soon as Python reaches it and is able to run it. The reason that this is useful is because we can use else cases as a catch-all for every other case that isn't caught by the conditionals beforehand. The reason it's useful is because we can use else cases. Let's look at this example. So we've created 3 zones visualized by the 3 colored rectangles. And let's say we made a game and we wanted the player to click on in the green zone to get let's say they get it correct. They get a point. They did something right. And they get an incorrect or they lose a point if they click on the red, right? Simple game. So there are many ways to go about this. But for simplicity, let's look at a case where we code it using if-else and a case where we code it using multiple ifs. In this case, we've used 3 if statements. One checks if we clicked with an x value from 100 to 300, which is our correct zone. Another case checks if we clicked from our mouse X from 0 to 100, and which is going to be our left red sidebar, and a third if case to check if we've clicked from X equals 300 to 400, the right red sidebar. This code will work. Clicking on the red zones gives us an incorrect in the console, and clicking in the correct zone in the green will send a correct to our console. Using an else case, an if-else case instead, we check if we click from 100 to, if with an X of 100 to 300, and send correct, in quotes, to the console, if so. Instead of thinking about this in terms of 3 separate zones, we can simplify it as being the green zone, correct, and not green, incorrect. So it's a case of inside and outside. Our else case, as we mentioned, is a catch-all. Anything not run by the conditional before it will be caught by the else case. So if our if case, which is checking for if we click the green, fails, we run whatever our else case runs. And in this case, it will be to print incorrect. And you can imagine if our zone was a lot more complicated, like this, we would have to do a lot more, we would have to split this up into more than just 3 areas like we did with the previous red and green combination. Of course, CSA or CS Academy has an entire cool toolkit of commands and functions that would make something like this like very easy, no hassle, such as like the hit shape function. But if we were thinking of this in purely coordinates, purely with coordinates, then using an if-else statement would make our life a lot easier. So you can imagine with this example, having, let's say, like, what is that? 1, 2, probably like 8 different, 4 or 8 different if statements, checking for like each side, each corner of around the green square, and it can be very complicated. Whereas if else, we just boom, did we hit inside the green or do we not? And this is when we would use if else over multiple ifs. It also makes a code a lot like easier to read, and it makes it a lot more efficient, more compact, and we catch bugs a lot easier instead of having to go through 20 different if statements and checking if what went wrong with that one. It's if else, lot less code to deal with, and less likely that we'll run into a bug.
So tip number 3 would be draw a picture of your if statements. So code tracing is an important part of clear and correct coding. You can do it with many more like simple lines of code, but a lot of people don't know that you can also visualize and code trace within your if statements. Because there are many different conditionals and scenarios, it will be a little bit harder to do just like writing out like what will print. You're going to have to visualize it a little bit more, and you can do it with if statements. So you can visualize each code block a little separately. So in my code example that I've provided, we first create a circle. And then we already know it's a circle because it's coded there, but say that like C was initialized by someone else and you don't know if it's a circle or if it's a square or whatever it is. Then the first if statement is asking, oh, is C actually a circle? And if C is a circle, then it would make app.color equal to white. So if we look at our little map on the bottom, we can see on the left, it asks, is it a circle? And if it's true, it'll draw an arrow to one, like a certain code block, or if it's false, it will go to a completely different code block. So then if it's true, app.color will equal blue or white or whatever the code says, and then you would put it there. And then for if it's a circle, then it would be false. And then if it's false, it would go to the else statement because it is an if-else statement. There's no else to complicate it. So then you would go to the else statement, and then you would check if it's a square. And in this case, you can see that if it's true, it'll do something, or if it's false, it'll do something different. So in this case, you can kind of see an overall picture. If it's a circle, it'll be blue. If it is a square, it'll be red. If it's anything else, it'll be green. And those are the right three code things that you can see. So those are your overall results that could possibly happen. And then if is circle or if is square are the conditionals that help you decide which color it will be. So that's like a really good way that you can visualize what you want to happen. And you can also see in the code block to that right that there are if statements within else statements or within like other if statements. It's all possible. So you can use multiple if statements within each other. And that's something to keep in mind based on what you want your results to be.
Finally, let's go over some of the 3 tips that we went over in today's workshop. So tip number 1, we talked about nested and inline conditionals. Basically, you just want to remember to make sure and check that if you are intentionally putting your conditionals in inline, or if you're intentionally putting your code or your conditionals nested to one another, because of course, as we mentioned, the two cases can lead to very, very different outcomes. So we want to make sure that we know what Python is reading as we write our code. So and hopefully save ourselves some time from having to debug and go back and like, oh, I forgot a tab, I forgot a space, oh, Python was reading it like this when I thought it was reading it like this. No, so now that's tip number 1. Tip number 2 is just a simple way of visualizing how our elifs work. Think of them as putting our code into a chain where only one entrance and only one exit is allowed. So every if-elif statement in that chain can only be checked if the one above it fails, and only one statement in that chain can pass. Once one passes, Python skips over any other remaining on that chain. And lastly, drawing pictures of your if statements. This is a very good practice. It's a practice that even us students use. It's called code tracing. It's just a way to visualize how Python is running through your code, and basically visualizing it as a map, and what is the route that Python is going? Like, where does it start and where does it end? Like, with each step, how does it transform? How does it change my function? How does it change my variable? And it's just a very good practice to debug and write your code much more efficiently and find bugs before they actually become a problem. So that's it. Thank you for watching, and happy CSE week.